So in this video, I will be covering pipes and cisterns questions. I will be covering the most important questions and the repetitive questions that are there in the pipes and cisterns, which are repeated most of the times, the types of the questions that are repeated most of the times. And actually, I would suggest, if you guys have not watched Time and Work, I would suggest you guys to go first for watching Time and Work and then come for pipes and cisterns. Why? Because actually pipes and cisterns, you can consider it as a continuation part of Time and Work. The concepts which are there for the pipes and cisterns, they are kind of similar to that of the Time and Work. You can consider it as continuation part, right? Okay, now first of all, and the basic points that I would want you to remember, is that there in pipes and cistern questions there can be inlet pipes, right? Inlet pipes means what? Which are filling the tank, right? Like for example, here A and B are filling the tank, so these are the inlet pipes. And then we can have the outlet pipe also, which is actually removing the water from the tank, which is emptying the tank, right? So in this very first question, we do not have any emptying pipe. We just have, this is the most basic questions that you can have for pipes and cisterns, which is just two pipes that A and B are filling the tank in some amount of hours. And while working with pipes and cisterns questions, whenever like in Time and Work, you were considering total work as a LCM of the 2 hours or 2 days or anything, right? Here also similarly, you can consider 36 and 45 LCM as your total capacity. There you are having total work as your LCM, here total capacity is your LCM, right? Otherwise you can go with writing the similar constant, like C or something like that. Just here 36 and 45 LCM you can easily find. You just go with the LCM, right? So A is actually filling the tank in 36 hours, B is filling the tank in 45 hours, right? Here you can consider C as your total capacity, or you can find LCM of 36 and 45. Now how you find this LCM? First of all, boil these numbers until you get the co-prime factors. So co-prime factors are 36, that is 9 into 4 and then 3, 3, 2, 2. So 3 into 3 to 2 into 2 are the co-prime factors of 36. Similarly for 45, it is 9 into 5, which is 3, 3, 5. So first try to find out the common numbers between the co-prime factors of both of these numbers. So here we have 3, 3, here also we have 3, 3. We do not need to write that 3, 3 again. Here we have 5, here we don't have, so we just need to write that 5, which is 9 into 4, 36 5s are 180. So 180 liters is your assumed tank capacity. So 180 liter is your assumed tank capacity, you can consider. Similarly, like efficiency formula that I have written, what is the efficiency formula in Time and Work? It's the same efficiency formula that we will be using here also. So efficiency is equals to total work upon number of days or hours, right? Number of days or hours. So this is our efficiency. Similarly, here also efficiency formula is same. So what would be the efficiency of A? A's efficiency would be 180 liters. Here your total work is actually your total capacity, right? So total capacity, that is 180 upon 36 hours. So in 36 hours, as A can fill the total tank in 36 hours, so 180 upon 36 would be, it's that is 5 liters. So in 1 hour, what is efficiency? It means the amount of work that you can perform in 1 hour or in 1 day. Based on the question, we will say if it is hours or day. As here we have hours, so in 1 hour A can fill 5 liters of the tank. Are you guys clear? So here, as in the Time and Work, we were saying that A can perform 5 units of work in 1 hour. Here we will say in 1 hour A can fill 5 liters of the tank. So in 1 hour it is 5 liter. Total is 180, right? So total 180 liter will be filled in how many liter? It is actually 36, right? Here we have 36 already. It is already given, right? Now similarly for B's efficiency, it would be 180 upon 45, right? So 45 4s are 16, right, 45, 4s are 180. So in 1 hour we can fill 4 liters of the tank. What is the question? How much if both are opened, right? Both are opened means what? Both are working together. In the time and work we were saying that if both of these people, they are working together to do this task, how much time would they require, right? Similarly here, if both of the pipes are opened simultaneously, which means both of the pipes are filling the tank at the same time, how much time will be taken by them to fill the tank? It will be similar. So in 1 hour, as individually they can complete 5 liters and 4 liters. So in 1 hour combinedly 9 liters can be filled by both A and B if they are working together. So 180 liter would be filled in how many hours? That is our question. 180 upon 9, which is 20 hours. So 20 hours will be the time which is required for both A and B if they are filling the tank together. This is our second question. Here we have two pipes which are filling the tank in 10 and 12 hours, while the third pipe is actually emptying the full tank in 20 hours. So if all of them are working together, how much time will they take to fill the tank, right? So as I've already mentioned, in the pipes and system questions we can have inlet pipes as well as the outlet pipe. So here the third pipe is our outlet pipe. Why? Because it is emptying the tank. Now what exactly first? So just consider pipe 1 as A. So A is filling the tank in 10 hours. B is filling the tank in 12 hours, while C is emptying the tank in 20 hours. Even though it is emptying, we will write it like this only, and we will get the LCM of this to get our total capacity, our assumed total capacity. Otherwise you can just go for C. Here we will get our LCM as our assumed total capacity. So 10, 12, 20. Write down the co-prime factors. So that is 5 into 2. Here it is 4 into 3, 5 into 4. This is 2 into 2 into 3. This is 5 into 2 into 2. This is 5 into 2. So first is 5 into 2. Already we have 2 here, right? We just need to write this 2 and 3 again. Here now from this and this we will try to find the common one. We already have 5. We have these 2's, right? You actually have all the things. Now if we multiply this, that is 10 into 2, 20, 22 are, 10 2 is 20, 23 is 60. So 60 liters you can consider as your total capacity. What would be the efficiency of A? A's efficiency would be 60 upon 10. Why? Total capacity upon number of hours A is taken to fill the whole tank. That is 60 upon 10, which is 6 liter. Similarly, B's efficiency would be 60 upon 12, which is 5 liters. And C's efficiency would be 60 upon 20, which is 3 liters. Now, just remember this fact. Whenever you are getting the efficiency of outlet pipe, you will denote it in negative sign. So it is minus 3 liter. Why? Because it is emptying the tank. So this is actually minus 3 liters. It is not adding the water, right? It is emptying the tank. Therefore, we will take it as minus, right? Now, if they are working together, means what? In 1 hour, first of all, in 1 hour, actually I have already said that if efficiency means what? It is 1 hour work. So here it is 1 hour filling. It is 1 hour filling. In how many liters can be filled in 1 hour? That is here. So in 1 hour, A can fill 6 liters. In 1 hour, B can fill 5. In 1 hour, C can empty 3 liters. Effectively, in 1 hour, 6 plus 5 minus 3. That is 11 minus 3. That is 8 liter. 8 liter what? Plus 8 liters. We have got plus here, right? Plus 11 minus 3. That is plus 8 liters. So, in 1 hour, effectively, our tank is getting filled, right? So total 60 liters will be filled in how many hours? That is our answer. That is 60 upon 8. So 60 upon 8 is the hours that are necessary if these 3 pipes are working together, 60 upon 8 will be is the hours that are required for filling the tank. So this is our third question. Here 2 pipes are functioning simultaneously and the reservoir will be filled in 12 hours. One pipe fills the reservoir 10 hours faster than the other, and how many hours does it take to the second pipe to fill the reservoir, right? So here, if both of the pipes are working together, which means consider pipes as A and B, if they are working together, they can fill our reservoir in 12 hours. So in 12 hours. Now in this type of questions, you can consider your total capacity as C only, right? You can just consider as C or any random number which you think can be divisible by 12. Otherwise, I'm going to take C here as your total capacity. So as A plus B can fill the tank, can fill the reservoir in 12 hours, what would be the efficiency of A plus B? A plus B's efficiency would be C, which is our total capacity. Total capacity by 12, right? Because efficiency formula is what? Efficiency formula is total capacity upon number of hours they are taking to, it is some any kind of pipe or anything is taking to fill that complete tank. So it is 12 hours for both A and B. So A plus B's efficiency is C upon 12. Now, one pipe fills the reservoir in 10 hours. Consider A is filling the reservoir in 10 hours. One pipe fills the reservoir in 10 hours faster than the other. If consider your B, just consider your A is filling your reservoir in X hours. So B will be filling it in 10 plus X hours, right? Because one pipe is filling the reservoir in 10 hours faster than the other, means 10 plus X. So B would be 10 plus X and A is X, right? Now, then what would be the efficiency of A? A's efficiency would be what? It would be total capacity, that is C, upon number of hours it is taking, which is X, right? Similarly, B's efficiency would be total capacity, that is C, upon number of hours, that is 10 plus X, right? Now, if you want to substitute this A's efficiency and B's efficiency in this equation, you can directly substitute it. You can substitute efficiencies in any efficiency equation. Other than that, you cannot substitute days or anything like that. So now substituting this in this, we will get C plus X plus C plus 10 by X, 10 plus X, C by 10 plus X, right? So C plus X here, C by 10 plus X in the place of B. So which is equals to C by 12. Why? Because this is also efficiency, this is efficiency, and this is efficiency. This is A's efficiency, this is B's, and this is A plus B's, right? Now if we just cancel this C out here, we will get 10 plus X. If we just cross multiply this, 10 plus X by, just have to multiply this. So 10X plus X square, which is equals to 1 by 12. Now again, if we just cross multiply it, this is 10 plus 2x, right? 10 plus x plus x means what? 10 plus 2x. So 12 into 10 means what? 120 plus 2x into 12 means 24x, which would be equals to what? 10x plus x square. 10x plus x square. Now, so if you just take all these terms to that side, on the right hand side it would be x square plus 10x minus 24x minus 120 is equals to 0. Am I right? Now x square minus 14x minus 120 is equals to 0. Now finding the factors of 120. Here minus 24x is here, minus 14x, and then from this we have minus 120. Now finding the factors of 120, from which we will get two numbers which can be by subtracting that two numbers we will get 14. Why subtracting? Because we have minus 120. If instead of minus 120, if we would have plus 120, we will consider we will consider two numbers where we can get addition of these two numbers, right? Now here we will consider subtraction. So 120's factors, how we will find it out? Just 2 into 60, 2 into 30, 2 into 15, right? again it is 3 into 5. Right? Now try to get the two numbers, try to minimize this into two numbers, which from which we can get minus 14x. So 5 into 3, 15, right? So just consider these two numbers randomly. 5 into 2 into 2, which is 5 4s are 20, right, into 6, which is 120, right? Now if we subtract this, we will get minus 14. So we have got our two numbers. So this is now x square. If we need actually minus 14, so minus 20x plus 6x minus 120 is equals to 0. So x minus 20 plus 6 x minus 20, so x is equals to 20 and minus 6, and our hours cannot be in negative form, therefore 20 is our answer, which is, so therefore x value is 20, which means A is taking 20 hours. So A is taking 20 hours and B is taking what? 10 plus 20, which is B is taking 30 hours. What is our question? We have to find out how many hours does it take the second pipe to fill the reservoir. Second pipe, so the one that one pipe fills it in 10 hours faster than the other. So other, that is our x value. So our answer is 20 hours. And then for the second pipe, it would be 20 plus 10, that is our 30 hours. So one pipe is taking 20 hours and second pipe is taking 30 hours. So this is our fourth question. Here we have two taps filling the water in 12 minutes and 15 minutes. And then there is one waste pipe in the system, right? So here these two are inlet pipes and this waste pipe means outlet pipe. So when all of these three are opened, which means now here we can consider these three of the pipes are working together, and then they will empty the cistern in 20 minutes. The empty cistern is full in 20 minutes, which means when these three are working together, they are filling the total cistern in they are filling the cistern in 20 minutes, right? And filling the empty cistern, right? So cistern is initially completely empty when they start filling the cistern. So first is consider A as your first pipe, and A can fill the water in cistern in 12 minutes. Similarly, the second pipe, which is B, this is the inlet pipes. So just mark them as plus. And then we have the third pipe. Just consider there is a C and mark it as minus. Why? Because it is the outlet pipe. It is empty in our system, which can it is not actually mentioned, right? So just consider it as x minutes. Now in this kind of cases, you can just go with total capacity as C, right? You can go for you can just actually take the LCM of 12, 15 and 20. Why? Because when A plus B plus C are working together, they are filling the cistern in 20 minutes. You can consider taking LCM of this 12, 15, 20. I'm actually gonna go with the C in this particular question. So our total capacity is C here. So what is the efficiency of A? It would be total capacity upon 12, that is C by 12. Similarly, B's efficiency would be equals to C upon 15. Similarly, C's efficiency would be equals to C upon X, right? Because it is taking X minutes to empty the system. So this is our outlet pipe, because this is emptying our system, right? Now here total A plus B plus C efficiency would be equals to total capacity C by 20 minutes, right? Now you can substitute these particular efficiencies in this equation, right? After substituting this, we will get C by 12 plus C by 15 plus C by X equals to C by 20. You can directly eliminate this C here. Now you have just one variable, that is X. You can directly find out X. So 1 by 12 plus 1 by 15 plus 1 by X is equals to 1 by 20. So you can just take the LCM here. What is the LCM of 12 and 15? Take it at 60, 60 just, yeah. So 5 by 60, multiplying this with 5, multiplying this with 4, so 4 by 60 plus 1 by x is equals to 1 by 20. So this is 9 by 60 plus 1 by x equals to 1 by 20. So our 1 by x, what would be 1 by x equals to? It would be 1 by 20 minus 9 by 60. Now here also we can take the LCM, which is and actually you will get the efficiency of x, like total efficiency would be minus, right? Yeah. So here you can you can just take the LCM of this 20 and 60. It is 60 only. So 3 minus 9 by 60, which is minus 6 by 60, which is 1 minus 1 by 10. 1 by x is minus 1 by 10, which is x is equals to minus 10. So actually x is 10 minutes only. So it is 10 minutes, right? So our x value is 10 minutes. So how long will it take the waste pipe to empty the full cistern? Just remember the fact, when we have written this particular equation, we have taken our efficiency as plus, therefore we are getting this as minus. Actually ideally you should have taken this as minus. You would have got the x as 10, right? Just 10. But here we have got minus 10. Why? Because we have initially taken this as plus, therefore we have got minus. But actually our answer is 10 minutes. You can eliminate this minus here. We will get x as 10 minutes. Therefore the waste pipe, that is our C, is taking 10 minutes to empty the full cistern. So this is our fifth question. Here an electric pump is taking 3 hours to fill a tank, and because of a leak in the tank, it is taking 3 into 1 by 2 hours to fill the tank. If the tank is full, right, how much time will the leak take to empty it? Right. So first we have one inlet and one outlet. Consider A as our inlet. So inlet pipe, that is our filling pipe, it is taking 3 hours. Right. And then our outlet pipe, how it leak in the tank. Leak in the tank is taking, it is not given, right? Just x hours. It is taking x hours to empty the tank, empty the full tank. This is leak L. Now together, because of a leak in the tank, it took 3 into 1 by 2, that is 3 into 1 by 2 means what? 6 plus 1, that is 7 by 2 hours. 7 by 2 hours are getting are required when leak and inlet both are working together, right? When there is a leak in the tank, which means outlet and inlet both are working together, which means A plus L is actually equals to 7 by 2, right? Remember, here also we have taken plus initially. You have to remember the fact, whenever you are taking plus, you will get your answer in negative. If you are taking subtraction, you will get your answer in positive, right? Efficiency you will get in negative. And now as A plus, what would be the efficiency? Consider your total work, its total capacity as W, or as C actually. Consider total capacity as C. Then what would be A's efficiency? A's efficiency would be C by 3. L efficiency would be C by X, right? Total capacity upon number of hours. If we substitute this in the, actually this is our equation. We need to we need to convert this into efficiency, which means C upon 7 by 2 means what? 2C upon 7. Understood? Now if we substitute this A and L value in here, we will get our equation. So that is C by 3 plus C by X is equals to 2C upon 7. C are eliminated already. So 1 by 3 plus 1 by X is equals to 2 by 7. So 1 by X is equals to 2 by 7 minus 1 by 3. So that is 6 minus 7 upon 21, that is minus 1 upon 21. I have already told you here, right? So minus 1 by 21. I have already told you, whenever we are writing this equation of the leak, initially if it is writing in the efficiency equation in plus here you will get your answer is minus, right? Therefore, so 1 by x is minus 1 by 21. That means x is 21 hours, which means leak will take 21 hours to empty the full tank. Right? If the tank is full, our leak will take 21 hours. So this is our sixth question. Here, two pipes can fill a cistern in 14 and 16 hours, and then pipe are opened simultaneously, and it is found that due to the leakage in the bottom, it took 32 minutes more to fill the cistern. When the cistern is full, in what time will the leak empty it? Right. Now in this question, we have two pipes. These are two inlet pipes. Let's consider this as A, which is taking 14 hours, and B, which is taking 16 hours. Right. And consider your total capacity as C. Right. And now, due to the leakage, it is taking 32 minutes more. Now, as it is in hours, just to make sure when you are solving any kind of questions where there are different, units are used, make sure you first of all make them same. As already these are hours here, you have to convert this 32 minutes into hours. So 32 minutes upon 60 would be our hours, right? So this is if you just divide it by 4, it is 8 upon 15, right? So this is our hours. Now the pipe are open simultaneously, and it is found that due to the leakage, it is taking 32 minutes more, which means previously it was taking, consider as x minutes, it was taking x. For example, if A and B, they were working properly without leakage, right? Because of the leakage, it is taking 32 minutes more. Without leakage, it would be A plus B would be C upon let's say x, right? So it is the efficiency, right? So A efficiency is what? A efficiency is C upon 14, B efficiency is C upon 16, right? Substitute here, it would be C upon 14 plus C upon 16 is equals to C upon x. So 1 upon 14 plus 1 upon 16 is equals to 1 upon x. What is the LCM? What is the LCM? It is 112, right? So if we just multiply 14 with 7, if 14 7s are what? 14 8s are 112, right? So 8 upon 112, similarly 16 7s are, that is 7 16 7s are. So it is 112, which is 15 upon 112 is your 1 by x. What is x here? It is number of hours it would take if just A and B are working together. If A and B are working together, in how many hours our tank will get filled? It will get filled is our x. It is x hours. So that is our x. So which is x is our 112 by 15 hours. So if there is no leakage, amount of hour that are required is 112 upon 15. I hope you understood why we have taken only A plus B first. Why? Because due to the leakage, it is taking 32 minutes more. So without the leakage, that is initial condition was what? They were working properly. They were working smoothly without any leakage, right? So for that, if A and B are working together without any L, it would be C by x. X here is what? X here is what? What would we write here? Just because without efficiency, it will be like x hours. When A and B are working together, it would take x hours for them. If we just write in the efficiency form, it would be total capacity upon x hours, right? So therefore, this is how we have found x is equals to 112 upon 15 hours. Now, because of the leakage, let's consider this L is taking total, it is taking L hours, not L hours actually. Consider it as P hours. So L will take P hours to empty the total full tank. L will take P hours to empty the full tank. What would be the efficiency? L efficiency, it will be total capacity upon P, right? Now when A plus B plus L, they are working together, A plus B already know it, right? A plus B is what? 8 upon it is similarly like that, right? So C by 14 plus C by 16 plus C upon P, which is equals to what? Already we already know that it is 32 minutes more. 32 minutes more means what? C upon 32 minutes more. Initially it was X. So C upon total hours are, initially it was 112 upon 15 plus 32 minutes, which is 32 upon 60. Am I right? Or directly you can write it as 8 upon, otherwise you can just directly take this LCM and go 60 will just go up. So C already cancelled. I hope you understood why we have taken here 112 by 15 plus 32 by 60. Why? Because due to the leak 32 minutes more are necessary, more are required. So when we are considering the leak, initially what we have taken C by X. Why? X hours are required if just A and B are working. Now there is a leak, right? So 112 by 15 hours are required plus 32 minutes more. Therefore 112 by 15 plus 32 by 60, right? Now therefore we already know 1 by 14 plus 1 by 16 is what? It is 15 by 112. So 15 by 112 plus 1 by P would be equals to, here we will get 60, right? If we just multiply here with 4, we will get 60 in the denominator. So it will go up, in the numerator. So 112 into 4, which is 448. So 448 plus 32, right? So therefore it is 15 upon 112 plus 1 by P is equals to 60 upon 480. Therefore 1 by P is equals to 60 upon 480. Okay, just wait a minute. Right here, let me just write. So 15 upon 112, that is, now 1 by P is equals to what? 60 upon 480 means what? 1 by 8. So 1 by 8 minus 15 by 112. We already know if you just multiply 14 with 8, we will get 112. Therefore LCM of this, we have to multiply this with 14. So 14 minus 15. So 14 minus 15 upon 112. So minus 1 by 112. You already know we have initially taken plus L. Therefore we will get our answer is minus. So 112 hours. So 112 hours are necessary if the cistern is full, and this leak will take 112 hours to empty the total tank. This is our 7th question. Here pipe A and B can fill a cistern in 36 and 45 minutes, which means A in 36 minutes, B in 45 minutes. Then our water pipe C can empty the tank in 30 minutes. So this is, C is 30 minutes. So this is plus, this is plus, this is minus. Now first A and B are opened. First A or B are opened, then after 7 minutes C is also opened, right? So therefore for this 7 minutes, for initial 7 minutes only A and B are opened. Now you can consider first of all LCM of 36, 45 and 30, which is 180. So 180 liter is your total capacity. Total capacity is what? 180 liters. Therefore what would be the A's efficiency? 180 upon 36, which is 5 liters. B's efficiency is 180 upon 45, which is 4 liters. C's efficiency is 180 upon 3, that is 6 liters. Minus 6 liters, right? It is minus 6 liters efficiency. Now 180 upon, right, this is minus 6 liters. Because why? Because this is the outlet pipe. This is our leakage, or like not leakage here, just emptying the tank. So there is a pipe which is emptying the tank, which is an outlet pipe. Now initially for the initial 7 minutes A and B are only working, because after 7 minutes C is opened, right? So initially for 7 minutes only A and B are working. So in 1 hour A plus B can actually fill 5 plus 4, that is 9 liters of the water, 9 liters of the tank. So in 1 hour it is 9 liters. Not 1 hour, actually 1 minute. it is everything is given in minutes, right? Therefore we will go for minute. So in 1 minute it is 9 liters. Why? Because actually we have found out the efficiency is in minute only. These 36, 45 are minutes only, right? Therefore it is, we have to consider that in 1 minute only A and B can fill 9 liters. So in how many minutes? Sorry, in 7 minutes. In 7 minutes, how many liters will be? How many liters of the tank will be filled? It would be 9 7 63 liters. Am I right? So 63 liters of the tank is filled. Consider this is x liter. So x is equals to 9, that is 63 liters. So initially 63 liters is already filled. Now our total tank capacity is 180, which means 180 minus 63 is left, right? So 117 liters is left, is remaining still. Now this 117 liters has to be filled by A, B and C together. Why? Because now C is also opened. Now C is also opened. Now and C is a leak, right? So therefore A plus B plus C is equals to what? Total capacity upon it is given, it is not given. That is what we have to find out. So this is x minutes. Consider it as x minutes. What are the efficiencies of A, B, C? This is 5 plus 4 minus 6, right? It is minus 6, which is equals to C, which is our C's total capacity. This is 180. It is 180 upon x. Am I right? Now this is 9 minus 6, that is 3. So 3 is equals to 180 upon x. So this is, we can cancel it here, 60. So therefore x is equals to 60 minutes. Now it will take 60 minutes for them to, fill the entire. Like, so sorry guys, it is not 180 because 180 is our total capacity, but like these three have to now only fill this 117 liters. We do not need 180 because already 63 liters is filled, right? So this is not 180, this is actually, sorry, this is 117. I'm so sorry. Okay, so this is 117 because 117 is our remaining capacity. I'm so sorry. So so 3 is equals to 117 upon x. X is our what? The number of hours, number of minutes that are necessary when these three of them are working together. Means A and B are filling and C is emptying. So when they are working together, x minutes are necessary, x minutes are required, which is x is 39. 117 upon 3 is 39. So now 39 minutes are necessary for A and B and C working together, and already 7 minutes are completed, right? Already 7 minutes are done. So 39 plus 7, that is 46. 46 minutes are required to fill the entire tank.